guys, welcome to Topic 5 Calculus in the Math HLAI course. This is just going to be a brief introduction to differentiation. So firstly, it's important that we understand what differentiation is. In simple terms, it's finding the rate in change of a function. This is an extremely important term, rate in change, as it kind of sums up exactly the whole point of why we differentiate. A function here can be notated as f of x or as y, and it's important to know that these two are interchangeable, meaning they mean the exact same thing. It's also important to know that in a question, it may ask you to find the derivative of a function. This term here is just asking you to differentiate that function. So if I'm asked to find the derivative of 2x, f of x equals 2x plus 1, I just have to differentiate that function. Okay, some more notation here. So like we said above, f of x and y are the notation for our functions. When we differentiate a function given in f of x, we will give it as f dash of x for our differential, and if it's given as y equals, then we will give our differential as dy over dx. Okay, just understanding a little bit more of what dy over dx means. It's essentially saying the rate in change, here's that term again, of y with respect to x, so in terms of x. So for example, if I had a function y equals 3x plus 2, when I differentiate that, it will still be in terms of x. I will show you below how to do that, and you will give it as dy over dx when you give your differentiated function. Okay, so how do we actually differentiate? This is kind of the textbook explanation on how we differentiate it, but it can be a little bit confusing with all of the letters, so let me kind of explain what's going on here. So firstly, we can recognize y and dy over dx, so we can already pick out this is our function, and this is going to be our differentiated function. And over here it mentions that a and n are constants. Constants are just fixed values, so in this case that will be a and that will be n. So here I've just kind of written out, you can see this is the exact same format as what's given above. I've picked a function y equals 5x cubed. I'm going to teach you how to differentiate this now. So the easiest way, in my opinion, to remember differentiation is that there's two big main steps. Number one, you're going to multiply the exponent and the coefficient, and number two, you're going to subtract 1 from the exponent. I've also written here that it must be done in this order. This is extremely important. You must multiply first and then subtract 1 from the exponent. Also, just recognizing here, this is the coefficient and this is the exponent. It's very important that you're able to pick that out. Okay, so let's actually look at this function here. We're going to differentiate it. So the first thing I've written, multiply the exponent and the coefficient. So we're going to do 5 times 3. The way I like to think about it is that 3 kind of jumps down on top of the 5, multiplies it, and then you put this multiplied value as your coefficient. So you'll have 15, the x remains as it is, and then we subtract 1 from the exponent. So we subtract 1 and we end up with 3 minus 1 is 2. And this here is our differentiated function. And like I said above, it's extremely important that you write dy over dx to identify your differentiated function. And that would be your answer. Okay, let's do an example a little bit more complex. So when you have more than one part of your function, I would recommend splitting it up so you have different parts of it. This will definitely make it easier and you will be less likely to make errors, especially with sign errors, as this example only has addition symbols, but when you have subtraction, you are more likely to make a sign error. So I would definitely recommend splitting it up. Okay, so firstly, let's start by doing the first part of this function. We're going to multiply the exponents. Remember, step 1 is to multiply and step 2 is to subtract. So the 2 is going to come down on top of the 3 and we're going to multiply and we're going to get 6, x remains, and then we're going to subtract 1. 2 minus 1 is 1. We don't actually have to write the 1 above the x, so we can just leave it as 6x. Okay, next part. We have the 2, positive 2, and we're going to multiply the exponent and the coefficient. Now the exponent in this case is just a 1, so 2 times 1 is 2. But when we subtract 1 from 1, we get 0, so there's no x anymore. The x cancels out. So we just have 2. Now for constants, a rule is just that whenever you differentiate a constant like this, it disappears. But as to why it disappears, I'll explain. So you're basically saying 3x to the power of 0 here. This is just 3x to the power of 0. When you multiply 0 by 3, you end up with 0. So therefore, you're just adding on 0, which you do not have to show. So this would be your differentiated function. Last step, make sure you show that this is your differentiated function with the correct notation, because it's in the form f of x, we're going to write f dash of x and then give our differentiated function like that. Okay, looking a little bit at what the first and the second derivatives are. So firstly, we have our function f of x. When we differentiate it once, we will get f dash of x, which will be our first derivative. And if we differentiate that function that we have just gotten again, we will end up with our second derivative. And I've given the notation here for the second derivative. If originally, like I've written here, it's in f of x, your first derivative will be f dash of x, and your second will just have two dashes to symbolize you have given the second derivative. If you have it in y, your first one will be dy over dx, and then your second one will be d to the power of 2y over dx squared. I always find this one a little harder to remember, so it's just important that you just get the hang of it from the start. Okay, let's do an example here where we'll find the first and the second derivative. So starting with the first derivative, let's say this is f of x equals 5x to the 4, 3x to the 3, 9x squared plus 3x plus 7. Okay, let's split our equation up into boxes. I'm just going to do it like this. It'll be a bit easier. Okay, so starting with this first one, we're going to multiply the exponent with the coefficient, bringing the 4 down on top of the 5, and we have 20x, subtract 1 from the 4 to the power of 3, plus 3 times 3 is positive 9x, subtract 1 from the exponent, we have 2, 9 times 2 is 18, x, 2 minus 1 is 1, so just to the power of 1, 3 times 1 is 3, subtract 1 is 0, so the x cancels out, and the exponent always cancels out there. So that is our final differentiated equation for our first derivative, and we will write that as f dash of x equals. Now for our second derivative, we literally repeat the exact same process, but just on this new function that we have created. And we do the same thing. 20 times 3 is 60. X minus 1 from the 3 is 2, plus 9 times 2, 18. X. 18 times 1 is 18, and then the constant is cancelled out here. So that would be our second derivative. Very important to notate it with the double dash, and we end up with this as our second derivative. Okay, lastly, I've just created a question kind of incorporating all the concepts I've touched on, just first derivative and second derivative again. So I suggest you give this question a go, and I will explain how to do it now. So firstly, the first derivative of this function. Same thing, split up your function like that. I'll put the boxes around it so we can see where the symbols are, because now we have some negatives. So firstly, negative 3 times by 3 is 9x. 3 minus 1 is 2, plus 2 to the power of 2 is 2 times 4 is 2 times 2 is 4. X, 2 minus 1 is 1, so we can just put that as 1. Minus 10 times by 1 is minus 10, and then the constant, you just get rid of that. Now notate it as f dash of x, and that will be our first derivative. Okay, for our second derivative, we're going to just differentiate the function again. So we take our first derivative that we have just found and we differentiate it. Okay, so we will end up with 9 times 2 is 18x, 4 times 1 is 4, and the constant, we just cancel that out. And then we notate it correctly, f to the double dash of x is equal to 18x plus 4, and that will be your final answer.